it's Deephaven community team back again with another demo. That's May week 5. First up, I've got to show you the grid docs that I've been working on. So let me just share my screen. Yeah, so with the grid docs, I've been, we added a much more, Donna actually added this part with an intro of what the grid is used for, what different flavors it comes in, an overview of all its features, and a quick start guide. This example is live as well. And if you go into the actual docs of how to use it, it has code samples that you can actually edit, and you can see the grid update in real time. So that's just kind of neat. And that works with all of our examples. So you can change the row count to say 5 things, and you see that update in real time. Group data. You can see it with the asynchronous data as well. So you can say increase this timeout to a really long time, so it simulates loading data in a really long time. It takes 5 seconds to load. There you go. This will be very useful for stuff like the theme, so you can actually update things in the theme and see it reflected immediately. So for example, if I wanted to just change the scroll bar background color, I can change it to red, and then I can immediately see that reflected in the theme below. So yeah, that's what I worked on this week, and that should be merging to our docs soon. All right, next up we have Devin. He's going to show us the embedded Python server across multiple versions of Python. So Devin, take it away.
Great, thanks, Bender. Let me go ahead and share one of my screens here. Not that one, this one. So first of all, Colin's done the majority of this work over the last month or so, and I'm just kind of showing off the end results here. I'm kind of putting it all together, but a lot of what you're going to see today is thanks to his work. So I've got a virtual environment here, Python 3.7, and the important thing to note is that we've got a JPY library here installed that is not Deephaven JPY. Deephaven has gotten push access to the JPY PiPi Repository, and this is a pre-release that we've gone ahead and done. And so this is a semi-official pre-release, again, not our Deephaven JPY. And so what this enables us to do is to invert the way we normally start Deephaven with Python. Normally what we do is we start a Java process and then have Python inside of that. But what we're going to do right here is we're going to start Python first, and then we're going to start Java inside of that. So what we do here is we grab a couple lines of code here. I'm going to go ahead and give it port 8307, so Python 3.7 here for reference. You can see our startup logging right there, and then what we can do is we can go ahead and go server.start. And now we have a server started on port 8307, and I'll show you that a little bit later in the web. But what we can do now is we have access to the Deephaven server Python API, so we can go ahead and import a timetable. We could go ahead and execute a command right here, and we've got a real ticking table. We can go ahead and print it out. This isn't going to print the data, it's just going to print a little bit of information about the table. And you can see, yeah, we've got a real engine table object here. It's got 8 rows when we printed it out. Now it's got 15, and gives you some column information over here. So we've seen Deephaven with Python 3.7. That's the version we ship with. But now, since we've got JPY as an external dependency being built for multiple Python versions and across Windows, Mac, and Linux, we can go ahead and do exactly the same thing on Python 3.8. So here we go, we've got a Python 3.8 on port 8308, same thing with Python 3.9, and same thing with Python 3.10. And as soon as Python 3.11 is released, we should have access there as well. And so this is, your typical Python interactive environment. We can do stuff here like you would normally do in Python. But what I'm going to do now is I'm going to jump over to the web and show you a couple of things there real quick to show you that, yeah, it is a real Python server and we can interact with it. that. So just to show you, here is the JPY PiPi repository. We've got a couple of pre-release versions pushed. If we go ahead and jump here and we look at the files, you can see we've got a variety of architectures that we support. Windows, AMD 64, Linux, and Mac OS for versions 3.10 through 3.7. This will probably expand in the future for M1 and other AMD or ARM 64 versions, but not yet. So what we can do here is our Python 3.7 console. Here's our Python 3.8 console. Here's our Python 3.9 console. Here's our Python 3.10 console. What I'm going to do is I'm just going to run the same command in all of them. I'm creating a table with the system version in it just so you can see it. We'll go ahead and show you. Yep, we're 3.10 here. We're 3.9 here. 3.8 here. And 3.7 here. And just for fun, to show off iframe support, we can see them all at the same time, 3.7, 3.8, 3.9, 3.10. So we've got a variety of options for starting from Python, and hopefully that'll be ship sheep and ready for next month's release.
Wicked. Very cool. That's exciting. All right, next up we have Colin to show off PlotBy functionality he's been working on. Colin, you're muted.
Right, thank you.
Yep.
In Devin's defense, he did a lot more than he's giving himself credit for there. A lot of the work has been trying to get JPY upstream, working with the stuff that we've already had. So this is PlotBy. PlotBy is a feature where you can take a single table and partition it in some way and plot each individual line. So we can say each of the lines we're going to plot here will be an XY plot, and we'll partition on this Z field. So Z here is just going to be a string, which is I mod 5, which is going to be 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. And then we've got I, and we've got, which is just the row number, against I times itself plus some offset. That way, each of the different lines plots a little bit differently. So
sorry, Colin,
itself,
Colin, can you zoom in a little bit?
Sure, sorry.
Just to make the font size a bit bigger. Yeah, perfect, thanks.
So each of the plots then shows up here. We should have a 0. Maybe we just don't have any data in 0. Anyway, I've only gotten this to work about 2 minutes before the call started. So a little more testing needs to be done. This data is terrible, and a great way to demonstrate the feature very well. But that's something we've at least got the basics of. How do you send the client the idea that there's multiple tables here inside this one object, and more tables might arrive at any moment, and how do you fetch each of the individual tables as they become important. So this is also going to be used for our one-click feature for filtering plots.
All right, very cool. Okay, next up we have Paul. He's going to show off the MLB Beat the Street.
Thank you, Mike.
Hey, Paul.
Here, let me. All right. So.
And same thing as Colin. Could you make it a little bit bigger? Just zoom in on your
yeah,
browser.
sure.
Yeah, perfect. Thanks.
That?
Yep, perfect.
Okay, cool. So, I've been assigned a pretty cool project, and I'm just gonna give a quick description. So, Beat the Streak is like this cool MLB game where you pick a player for that day that you think is gonna get a hit, and if you get 56 in a row, or I think it's more than 56 or something, you win $5.6 million or something before tax, but still a lot of money. And I've been put on a project with my buddy, the other intern, Josh Koski, to figure out how we can use Deephaven to create the best pick the best person possible for that day. So we've just, recently started working on it, and so none of this is going to actually win us $5.6 million, but it's just a start. So here we import a package, from a Python package called PY Baseball. And I'll just run it just to see it. It might take a while, but just a little bit.
Can you talk a little bit about what data is it importing?
So it's importing. I took 2 data frames from it, which this one, the data just gives us players' names and their hits and some of their stats. You can't hear. Let me zoom out just a little bit, or I'll quit this. Here, some player names and some of their stats and stuff. But then the one that's really interesting is this one. So it's a Panos data frame that gives you, it's almost like a pitch by pitch description of everything that happens. And so from here, you can get like, if it was a hit or if it was a ball, which will be super useful for what we're doing, because we're trying to create, prediction of whether or not someone's going to get a hit. So we can use this to create a program that can predict something. And then from this, I turn it into a table. I turn that into a table, and then this will give us a better. Here we go. So these are kind of going to be the main variables that we want to look at. What kind of pitch it was, and all the descriptions, and then the batter who hit the, because that's who we're going to be picking. And from this we want to create we're going to create a new stat called, we call it HPIGS. Kind of just made it up, but stands for game start. And that's obviously going to be very important to win the game.
So, sorry, can you repeat what it stands for again? You just broke up right in the middle there.
Oh, HPIG stands for hit per game start.
Okay.
Yeah.
Thanks.
Yeah. And so once we find that, we can be better at predicting which player is going to get a hit that day, and hopefully, and it will turn out well. But yeah, that's it. Thank you.
Yeah. So we're expanding our strategy into getting some winnings. I like it.
Yeah.
All right. Next up, we have JJ. He's going to show using the Crypto First API.
JJ, you're muted.
Thank you, Margaret, and thank you, Bender. So last week I gave a demo on using a crypto API to pull historical data. I actually found what I find to be a much better crypto API for historical data. I need to share the window, not a tab. It's called, oh, come on, are you serious? Google Chrome is apparently thinking that I have never shared before. Wait, what about this? Okay, let's try this. Can't share your screen.
Try sharing a tab.
Let me try. Oh. I have shared my screen many times using this, and it has never complained. Dismiss. All right, let's try this one last time. Okay, Deephaven. Hopefully you guys can see this. I would have liked to shown just CryptoWatch's website, but it's just cryptowatch.com. Go check it out if you're interested. They offer a free-to-use REST API that does not require an API key, which is pretty cool. Every 24 hours, if you do use their free-to-use REST API, you get 10 credits to pull data from the REST API. And that may not seem like much, but actual queries to the REST API don't require very much. For instance, if you want to pull a list of all the coins and exchanges and assets and things like that, it's only 2,000ths of a credit. So it's the equivalent of 0.2 of a cent or 0.02 of a cent or something like that, and then pulling data for a particular coin on a particular exchange is only 0.015 credits. So if you're interested in pulling historical crypto data, in reality, you get about 700 REST API queries a day without an API key. They also offer plans for more pulling than when you don't have an API key. But for historical crypto data, about 700 a day should get you a ton of data and everything you need to get started doing some historical crypto analysis. So I've got 4 scripts down here. These will be packaged into a Deephaven examples repository where some of this stuff will get run as an app mode script just to define some functionalities before you start. But I've got this utils thing. And as you can see here, I've got it printing out my usage. So for instance, when I pull a list of exchanges and a list of assets, or basically the coins that are there, it uses only 0.002 of a CryptoWatch credit. And you can see here that I have this many remaining, which just means that I've been playing around with it today. So now that I've got those things up and running, this is going to be the other app mode script. This will define the functions that I'll be using to pull the CryptoWatch data into Deephaven, and I'll be writing all of it into Parquet files. Up next, I just want to show that I have nothing right now. I have no Parquet files in my data directory. Everything that I'm about to do is going to write this data into the data directory so that we can see just how much data I'm getting from a single pull from the REST API. So hopefully everyone can read this just fine. Here I've got a list of 7 coins, 4 exchanges, 2 currencies, and 4 frequencies or 4 granularities. Anytime you pull data for a particular coin on a particular exchange, you will get granularities ranging from a minute to a week. And that all comes with a single API pull. So basically, there's a list of acceptable frequencies you can see in here. I could choose from any of these, but for the sake of this, let's just say I want a minute, an hour, a day, and a week. So I run this, and it's going to spend some time pulling a whole bunch of crypto data for particular coins, for particular currencies, and on particular exchanges. Failed to write Parquet file. That's a new one. Let's try this again.
Maybe a permissions issue if you cleared out the directory and.
I could have. Yeah, either way. So now when I come in here, we can see a bunch of these different files. I literally 5 minutes ago had this working for all of them. I'll just have to double check. I probably was very careless when I cleared out this data. But basically, for it would take about 0.7 total CryptoWatch credits for me to get all of this data for every single one of these coins. The only one that was missing was SafeMoon. Data doesn't exist on any of these exchanges at CryptoWatch. So in reality, when you do something like that, this thing is smart enough to just skip over them. And yeah, so I'm looking to turn this into a short blog piece as well as a Deephaven examples repository, and then use this for a learning session, hopefully next week, just to talk about standard practice when pulling data from a REST API in Python.
Very cool. And that's it for this week. We'll see you next week. See ya.